Okay, let's talk about this real quick. There's a trick here that makes this a lot easier to deal with. Check it out. All those fractions are pretty inconvenient. Anybody make a suggestion how we could get rid of them? Kill them. No, that's what we're going to do. Yeah.
Yeah, multiply them all by 4.
That's it. Yeah, this is called clearing the fractions. This is something, it's a really good trick. When you clear the fractions, all you have to do is you look at, here's when it's, a situation like this is when it's really easy to apply. When you have a bunch of terms that have fractions in them. All you got to do is look at all the denominators and find the least common multiple of all the denominators, meaning the least common denominator, of the fractions on both sides of the equation. So what would that be here? 4. Okay, so yeah, so we can multiply through everything on both sides by 4. And here's how you should do that. You shouldn't just multiply straight across. You handpicked this number 4 because all of the denominators divide evenly into it, right? And so when you distribute the 4, you should always cancel first, reduce the fraction and then multiply. In this case, it's not as big a deal because they're pretty small numbers, but what if they weren't? What if they were really big numbers? What I mean by that is when I distribute the 4, so when I distribute it to this first term, we just get, what, 4x squared. But when I distribute it to the second, instead of multiplying the 4 by the 3 and getting 12 divided by 4, instead, we'll say 4 over 4 is 1, and just multiply that by the denominator. See what I'm saying? So that gives us minus 3x. 4 over 2 is 2, which we multiply by the numerator, right? And same thing on this side. In this case, they just cancel, right? 4 over 4 is 1, so we get negative x, and then just minus 1, right? See how that works? And then in one move, now we've cleared all the fractions out of there, and now this is much easier to deal with, right? Okay, now moving on to the stuff. So that's kind of just a reminder of a good trick you can do. But now we're on to stuff we talked about. So now what do we do?
Yeah, put it all on one side.
Put it all on one side, okay? Sounds fair. If we put it all on one side, we're going to end up with, what, 4x squared. We've got to add x and add 1. Okay, now what?
Multiply c by
What do we do?
Multiply 4 to 3.
Okay, so you're talking about trying to maybe factor it?
Sure.
Okay, I'd recommend against that. I know we practiced it, but I don't think it's a good idea. It's rarely going to work, and it's just a lot of effort, time. Yep.
Oh, yeah.
Couldn't you move the 3 back over and then
Yeah.
complete the square?
Yeah. Let's complete the square. So really, we could have, moving it all to one side is fine. That's fine. But if you know you're going to complete the square, remember what we want to do. We want to try to get this thing in the form, when we're completing the square, we want to get it in the form x squared plus bx equals c, right? Something like that. And so we really just want to keep the x squared and the x term on the left, and so we don't even really have to push the constant this direction. We could have just subtracted 2 if we wanted. Okay? All right, so now we got to complete the square. How do we complete the square? What do we have to do? What's the first thing we have to do? Say it again. Take out the b. Okay. But before we even do that, we've got to get the coefficient of x squared to be 1. So what does that mean we have to do? Yeah, we got to divide both sides by 4. right? So if we divide each side through by 4, what are we gonna get on the left side if we split that fraction? So we get, what's the first term gonna be? X squared minus 1/2 x squared. Okay, so same thing as just saying, or x, 1/2 x. I could just say that as x over 2 equals negative 3/4. All right, now we're in position to complete the square, right? So remind me, how do we do that? What do we have to, we know that when we complete the square, and this is where I think it's maybe a good idea to even just, you can even just kind of set up the template of what you know it's going to look like, right? What number do I have to, well, what number is going to go here? It's going to be coupled with the x. B over, okay, good. It's going to be b over 2, and b is negative 1/2, isn't it? Right? So let's write that down. B is negative 1/2, so b over 2 is negative 1/4. And then what do I have to add to both sides to get that, though? Yeah, I've got to add this quantity squared, right? I've got to add b over 2 squared, right? So that's going to give us 1/16, good. Right, makes sense? Okay, which means then, we already know on this side what this is. The reason we added the 1/16 is so we can get this perfect square, right? We know that x squared plus bx plus b over 2 quantity squared is guaranteed to give us this, right? What do we end up with on this side? How many 16ths is negative 3/4?
Well,
Negative 12? Right. So negative 12 16ths plus 1/16 is how many? Okay. And now we're all set, right? Now we can just, now we have completed the square, and all we have to do is just isolate x, right? So what's that look like? First thing I would do would be square root. Good, if we're working backwards. You got to square root both sides. And that's going to give us x minus 1/4 equals what? 11/16 i? Square root of 11/16 i. Good. We've got a negative sign under the radical, right? And so we know that's going to turn into an I, isn't it? Right? So we're going to get a complex solution. That's fine. What else do we need, though, for square rooting both sides? Plus or minus. So we got plus or minus I times square root of 11 over 16. But what's the square root of 16? 4. Okay. So we could do something like this, couldn't we? Right? And then last step?
Why do we add 1/16 to it?
Because we're adding, remember what we have to do when we complete the square, we're adding, we determine what is b, and then we're going to add b over 2, half of b squared to both sides. That's always the recipe. When we add that, then we know that this is going to factor to x plus b over 2 quantity squared. Right? And in our case, b is negative 1/2, so b over 2 is negative 1/4. Right? Okay? So last step to get the x by itself? Add the 1/4. We're done. So then we'll just push that into there. So x would equal 1/4 plus or minus I times the square root of 11 over 4. Okay, got it. And that's about as hard a one as you could get. Okay? Questions on that?
Does the I have to be in front of this back?
It doesn't have to be. Our convention is that, like, if let's say we had an answer like this. Let's say our answer was, we got an answer that was 2 plus or minus 3 times the square root of 7i. What's the only problem with putting the I at the end there?
It's ambiguous.
Yeah, whenever we have a radical in our answer, we like to push the radical to the end, just to, kind of as a bookkeeping thing, just because if you put something after a radical, you always are wondering, is it underneath the radical or not? And so instead, a lot of times we'll push that I out in front of the radical. Doesn't make any difference though, in terms of whether your answer is correct or not. Okay? Questions on that? Does that make sense? So on the assignment that I gave you yesterday, it really just asks you to do a couple things. There's only 3 kinds of problems. It asks you to take some perfect square trinomials and factor them. Real simple. So you'd be getting things like this, for example. If you had x squared minus 6x plus 9, what is that as a perfect square trinomial? Yeah, you'd be doing that, right? Or if you had something like x squared minus 6x plus c, and you want to write that as a perfect square trinomial, what value would c have to have? It'd just have to be half of b squared, right? So it'd be 9. Okay, and then I asked you to, on problems like this, I didn't ask you to actually do the whole problem. I just asked you to get it to the point where it was a perfect square. It was written as a perfect square squared. So you just complete the square but don't solve for x, right? So you would have stopped at this purple step right here before we square rooted, okay? So next step though is going to be to actually, next assignment you'll have to kind of go through and just complete the square to get solutions. But there's another alternative here, and I know you already know this, but we have an alternative to completing the square. I actually prefer completing the square, but what's our other way that we could deal with a problem like, like this one right here, or actually like, I guess like this one, if we'd added the 3 to this side. Quadratic formula, right? We could also use the quadratic formula. But how do we get the quadratic formula? Let's talk about that for a second. How do we get the quadratic formula? The quadratic formula applies to any situation where we've got a quadratic equation in standard form, right? So standard form, of course, what's that mean? How would we write that? Just the general.
ax squared plus x.
Okay, but if it's a quadratic equation,
Equals 0.
equals 0. Yeah, and the 0 part is important because that's standard form, right? It said equal to 0. So you guys probably know the quadratic formula, but I want to go through really quickly and this is important to do in math. Let's prove it. Let's go through and derive the quadratic formula.
Or we could watch a video, a music video
No.
of the
Ooh,
quadratic.
stop.
No,
Not
no.
watching the
I showed you the
quad-
music
I love
video,
that.
right? Yeah.
No,
Okay.
no, it's like the one that Mrs. Robinson showed us.
Okay, so anyway, so how would we do this? How could we do this? How could we solve for x here? What do you think we could do if we want to derive the quadratic formula? And I want you to get a feel for why this is such a powerful thing to do in math. We just did a problem, a pretty hard problem, but it was specific, right? It was specific to these coefficients. I mean, it's one equation. What if we could replicate that process for starting here, right? Is there anything specific about this? No. This could represent any of the infinite possible quadratic equations, right? In standard, we can put any quadratic equation into standard form. And so this will always work. So if we were to do the same process here, what we're coming out with is not an answer, it's a formula. Because we haven't ever specified what any of these coefficients are, right? That's something we like to do in math. We like to work in generalities so our answer has much more meaning, right? So what would we do? What are the steps we'd go through here to solve this quadratic equation by completing the square? How about? What could we do? Okay, we gotta subtract c, get the constant on the other side, right? So ax squared plus bx equals negative c. Now, what were the other things that we had to have some other, we got to divide by a, okay? And if we do that, let's break this into separate terms. So first term is going to be x squared plus
Yes.
B over A times X, right? I could put the X on top, same thing. Everybody agree? Okay. Equals negative C over A. Okay, so we already know, now this is going to be a little inconvenient to call this B. I'm going to call it capital B, so we can separate it from this small b, right? So what is, we're going to call the coefficient of X here capital B. What is that? Capital B means coefficient of X. What is it? No. What's being multiplied by X? B over A. Yeah. So then what is B over 2? Capital B over 2. That's really just the same thing as 1/2 times B, isn't it? Right? So what's that going to give me?
1/2.
Okay, how can I write that in maybe a little simplified form? If I just multiplied, you're right, it's 1/2 times B over A. But if I just multiply straight across, that's what? B over 2A. And then what would B over 2 quantity squared be? Okay, what is that? If I were to distribute, use properties of exponents, I'm going to square this whole thing. What would I get on top?
P over 4A.
B squared on the top, right? Does everybody get where this is coming from? So all we're doing here is we're saying B over 2A quantity squared. Well, what are our properties of exponents here? We could split the top and the bottom, right? So that's the same thing as B squared over the quantity 2A squared.
Yeah.
And then on the bottom, the quantity 2A squared is the same thing as 2 squared times A squared, right? So we get, does everybody agree? Does that make sense? So B squared over 4A squared?
Yeah.
Okay?
Yeah.
Okay, so then now we can do our process of completing the square, right? We know that we're just going to, if we think about the pattern, we're just going to add B over 2 quantity squared. Oops. To both sides, right? And what that's going to give us is X plus what? Yeah, but I mean, so if I add, this is, pretend that's just, we're just going to call that B for a second. What we've got right here is just X squared plus BX plus, you told me B over 2 squared, right? On this side is just going to equal B over 2 squared plus whatever this is, right? Right. What is this always going to factor to every time? X plus capital B over 2, right? Quantity squared, right? Well, so then let's do that stuff. What is B over 2, capital B over 2 squared, you already told me, is just B squared over 4A squared, right? So we'll add that to both sides, right? And then that's going to give me this, right? That's going to factor to this, which is just the quantity X plus B over 2A quantity squared, right? Everybody agree? And then on this side, what are we going to get? Well, what would I have to do to combine these fractions? I got to get a common denominator, right? What's my common denominator going to be? It's going to be what? 4A squared. Okay, so what do I have to multiply this one by then? Yeah, 4A over 4A, right? To get a 4A squared on the bottom. Okay. So that's going to give me, I've got my common denominator of 4A squared. And on the top, that's just going to give me B squared minus C times 4A is just, we could call that 4AC. We agree? Okay. So that's what we've got down here. Okay, so we're all set. Now, I know this looks maybe kind of intimidating because there are no numbers, it's all variables, but that's okay, that's good. Right? Remember, A, B, and C just represent, when I say A, B, and C, I mean lowercase a, B, and C, just represent real numbers. Those are just the coefficients of x squared, x, and then our constant, right? So this is our answer, almost. We just have to solve for x. Questions? You want me to go up a little bit?
Yeah.
Okay. Okay, so what do we have to do next? We're just trying to solve for x. What are going to be our 2 steps in order to solve for x? Okay, square root first. Good. Square root would get rid of that, right? And then just subtract that term, right? Okay, good. Everybody see that? And then we'll have solved for x. Okay, can I scoot down a little bit?
Yeah.
Okay. So then let's do that. So let's square root both sides. So that's going to get rid of, if I do that, we're going to get on the left side x plus b over 2a. What are we going to get on the right side? Plus or minus the square root of this whole thing, right? Okay, but let's see if we can make that maybe even a little simpler. So I can split that apart into the square root of the top and the square root of the bottom. Right? That's a property of radicals. We agree? Okay. So then that's going to look like plus or minus square root of b squared minus 4ac. There's really nothing I can do with the top. But what about the bottom? What's the square root of 4a squared? Yeah, look at that. The square root. Oops.
What are you doing? You're showing us what the quadratic actually means.
So the square root of 4a squared, we can split that into the square root of 4 times the square root of a squared, which is just 2a. How about that, right? And so we get our 2a, right? And what's on this side? Remember, this was just same thing, x plus b over 2a. So last step? Yeah, subtract b over 2a from both sides. Is this starting to look familiar?
No.
So that's going to give us negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. But look, we've actually got a common denominator there, don't we? So I could write that as a fraction with just one big common denominator, right? So I could write it as
4a?
negative b plus or minus square root b squared minus 4ac all over 2a. Voila, quadratic formula.
I lost you at like
Wait a second. I got other problem.
Okay, so now if that's a lot of stuff, but for you guys, this is, I wouldn't probably go through this with, just regular algebra. I mean, I might show it to them, but I wouldn't be as concerned about them getting this. But for you guys, this is a big step, seriously. If you followed all that, awesome. If you didn't, I strongly encourage you to go back and look at this again, or just do it on your own. This is really, I'm not kidding, for you, this is a really big step to be able to take something. As I look forward at your math futures, I mean, I know, I've been there, trust me, I know where you're going. And you're going to be doing a lot of stuff like this, right? And just, once again, to appreciate this process. We're starting with, and this is really cool, we're starting with just that, right? And really think about that, appreciate that. That's as general as it gets. That is the definition of a quadratic equation in standard form. So we're starting with the absolute general first place we could be with a quadratic equation. And we're just doing algebra on that generic, totally general quadratic equation to solve for x.
Yeah,
And then as so now we've got x by itself, and our answer only includes a's and b's and c's, right? And so this means that regardless of what A and B and C are, this is the form that the solution is always solutions, because there's a plus or minus, that they're always going to take, right? Okay, so there's a part of this, though, that's kind of important. Now, let's think for a second about what quadratic equations look like. What does the graph of a quadratic equation always look like? It's going to be a parabola, right? Either opening up or opening down. Okay, so if we were to take, for example, let's just take this one. What if we have the quadratic equation?
My arm.
How about 2x and then 4?
I think we need to match it.
Are we doing
Wait,
it?
and what if you looked at what there's
No, Al. I thought you were writing.
I lost that. Give him that.
Oh, get it,
What did
Ellie.
you say? Oh,
I have a pop drop, not a pop drop. I want a pop drop.
It sucks.
I tried. But then I'm thinking.
Okay, what about that? Let's take a look at that real quick. So
Oh my god.
we could solve this pretty easily, right? But let's not. Instead, let's just look at this graphically for a second, right? If I just add 2 to both sides, I'd get x squared plus 8x plus 12 equals 0, right? So I'm going to pull up my graphing calculator. And I'm actually going to, I'm talking about this a little before I wanted to, but I think it works well with what I'm doing right now. So, and you know how to do this. If I want to, we've already done some stuff like this. If I want to solve this graphically, I can do that, right? Because what I'm interested in is where this quadratic function is equal to 0, right? What does it mean if I compare this to the quadratic function? Let's just say this part right here, we're going to call y. So we've got the quadratic function y equals x squared plus 8x plus 12. And if we're setting that equal to 0, what value in that function am I really setting equal to 0? If I start here and I go to this equation, what have I done? I did, right? I took this function, which can be represented as y, and by setting it equal to 0, I'm just asking the question, where does y equal 0, right? So what does that look like on the xy plane? Where does y equal 0? Well, at the well, you mean the
When
origin
x
problem?
equals 0, y.
Okay, what's that going to be though? No, you're onto something. But what is that? What is that? Y equals 0 is what line?
Y.
The x-axis, right? The x-axis. So if I graph this,
You had your chance. You had your chance too.
Well, that wasn't me. You blew it.
I know. I leave it up.
so x squared plus 8x plus 12, and let's just go. I'll just go zoom standard. How about just to reset the window? Zoom 6. And what do we notice? It's a parabola. What are our solutions going to be based on the graph? Let me make the graph bigger. How about?
No.
What are they going to be? -2 and -6, it looks like, right? How come? Because that's where the graph crosses the x-axis, right? Think what we did, right? We were asking the question, when does this function, meaning its y value, equal 0? Okay? So that's not atypical for us to get an answer like that, where we get 2 solutions. Okay, what if I change this very slightly? What if I change this to, I'm going to go change the function. I got to think for a second here. I'm going to make that a 16. Okay, and let's graph that. Okay, how many solutions does that have? That's only got one solution, doesn't it? Right? It's actually got a double root, but it's, in this case, the vertex is the only place that touches the x-axis, right? And so we get one solution. What if I had picked something like this? What if I had picked something like 17? Okay, how many solutions does that have?
0.
0. Okay. So we just saw graphically. Everybody, don't get distracted. Don't let yourself get distracted. If you do, you're gonna. It's not good. So we just looked at examples of really the only 3 kinds of things that can happen with a quadratic equation. If we solve a quadratic equation, most of the time the ones you're getting have, well, I wouldn't say that. I mean, a lot of times they have 2 real solutions or 2 complex solutions that have imaginary parts. Or you don't see this as often. I don't know if you got any of these on the assignment or not, but the other possibility was 1 real solution, right? We can see what that looks like graphically. How could you predict that from our new quadratic formula? If we go back to our quadratic formula, how could you maybe, yes?
If C is greater than 2B, there's no solution.
If C is greater than 2B, not necessarily. Not necessarily. I can see where you got that, but that's not the only case. Where would I look to determine on this quadratic formula if there's, and let me rewrite it so you can stare at it a little bit. Where would I look to determine how many solutions I'm going to have and of what type? So here's our quadratic formula. Remember the song? What is it? Come on now. Did you guys not hear the song?
No.
I really didn't show you the song?
I want to hear a song.
I want to hear it.
I know the song's actually helpful.
Yeah, but you should play it again though, honestly.
Okay, all right.
I
You
must
should
not-
play it
I
on
must
a loop
not-
every time we go into math.
I remember it.
Okay, where are we going to look here? What part of the quadratic formula is going to determine whether your solutions, for example, are real or have imaginary parts? How come?
Oh, because if it's negative, then it's gonna have an I.
Okay.
If it's negative, then it's going to have an I.
Yeah. Good. Okay, so now think about our 2 rules for real numbers that we've rehearsed over and over, and we'll do it more and more. 2 things we can't do for real numbers. We can't divide by 0, and we can't take an even root, meaning in this case a square root of. Yeah, if we do that, it's not real, it's imaginary, right? Well, where's the only place that can happen? So when we start to look for things like that, well, there's the square root. So the only place we'd be in danger of taking the square root of a negative number is when the value of the argument of the square root, what's inside it, is negative, right? And so this is really the critical part of the quadratic formula if we're trying to make a prediction about how many and what kinds of solutions are we going to get. Right, we call this the discriminant. I guess because it helps us discriminate between which type of solution we're going to get. The discriminant, it's D, capital D. A lot of times we'll write it as capital D, and it's just B squared minus 4AC. So what happens if the discriminant is positive? Which one of our graphical examples is that going to be? If we go back and think about remember we just looked at those 3 parabolas. Which one is that going to be? If the discriminant is positive, so the number under the radical is a positive number, then I'm going to get the square root of a positive number is just some positive number, right? A real number. How many solutions am I going to get then? 2. I'm going to get 2 because I'm going to be adding or subtracting that positive number in the numerator, right? I'll get 1 for each sign. Everybody agree? Okay, what if the discriminant is negative? What's going to happen? If it's negative, then what's going to happen to the number? What is the square root of a negative number? What's that always give me? An I, right? And so in that case, I'm going to get an imaginary number coming out of this square root, right? And I'm going to get two solutions still, but they're going to be complex, right? Because I'm one for the positive and one for the negative. But each of those two solutions is going to have an I in it, correct? Okay. Which one of the graphs would that correspond to that we looked at? Well, yeah, we could graph it in the complex plane, but it actually corresponds to this one. Why this one? Because x-intercepts correspond to real numbers, right? Remember that when the curve actually crossed the x-axis, you told me that the answers were -2 and -6. Those aren't imaginary, those are real numbers. Every number on the x-axis is a real number, right? And so if the curve actually does intersect the x-axis, that's giving us a real solution. If it misses the x-axis, then there are no real solutions. Instead, they're imaginary, right? So this is what the graph would look like for a quadratic equation where it only has real solutions. There are no x-intercepts, right? And then last case, what about, can you tell me, what would the value of b squared minus 4ac have to be for us to have exactly one solution?
0.
Have to be 0, wouldn't it? What's the square root of 0? 0. And so that means that term would go away. Negative b plus 0 is the same thing as negative b minus 0, right? So the plus or minus only gives us one solution in that case. Does that make sense? Okay. That's it. That's it. So what do we take out of this? If you want to predict, and I'll give you some questions like this, if you want to predict very quickly what kind of solutions you're going to get, just evaluate the sign. You don't even care about the number, just the sign of the discriminant. So for example, if I'm asking you, and I will, sometimes we only want the real roots. If there aren't real roots, we don't care. We'll just say, you know, we're only looking for real ones. What if you had this quadratic equation? Okay. Should I bother or not to solve that equation if I'm only looking for real solutions? What's A? What's B? What's C? Okay, so then the discriminant would just equal 1 squared minus 4 times 2 times -3. What's the sign of that for sure? Positive. So I got to do it then, right? Because I am going to have two solutions. And the thing about it is when you check the discriminant, if you see that it's going to be positive, we'll just figure out what it is and plug that into the quadratic formula so you already did some of your work, right? Does that make sense?
Sure.
Yeah. Okay, oh yeah, so. All right.
Bump them two.
Oh,
No.
Yes!
That's what I would do.
What? Ooh, get it, bro, get it.
Hey, boys and girls,
God,
are you ready to learn the quadratic formula side? Come on! X equals -b plus or minus square root b squared minus 4ac divided by 2a.
I remember this now.
Ellie, this is your bottom song.
Let's try it again. X equals -b plus or minus square root b squared minus 4ac divided by 2a. Let's do that again. Let's try and make it a little bit different. I don't know. Make it a little rockish. X equals -b plus or minus square root b squared minus 4ac.
Is there a dancing baby?
Good question.
Sing it a little bit.
I remember when Robinson's the PowerPoint they can't use. Yeah.